Picture yourself on the brink of a bubbling, steaming cauldron of geological marvels, where the earth shifts and trembles beneath your feet. This scenario captures the recent extraordinary events unfolding in Yellowstone. A surge in seismic activity, unlike anything observed in decades, serves as a stark reminder of Mother Nature's formidable power and capriciousness. The question looms, what is triggering this seismic commotion? Could it signal an impending catastrophe? Join us as we delve into the recent serious warning issued by a Yellowstone official following a barrage of hundreds of earthquakes in the national park. Yellowstone, where nature's majesty meets history. Yellowstone National Park sits proudly in the western United States, spreading its beauty across the northwest corner of Wyoming, reaching into Montana and Idaho. This vast park is famous for two things: its incredible wildlife and its amazing geothermal features. Among these natural wonders, the Old Faithful geyser stands tall as a crowd favorite, captivating visitors with its regular and powerful eruptions. While Yellowstone showcases various ecosystems, the subalpine forest reigns supreme, blanketing much of the park's landscape. Yellowstone's diverse habitats and amazing geological features draw in adventurers, nature enthusiasts, and scientists, making it a beloved gem of nature. In ancient times, long before Yellowstone became a national park, it was inhabited by various Native American tribes, including the Crow, Shoshone, and Blackfeet. These tribes not only lived in the area but also considered it sacred. While much of their history is obscured by speculation, myths, and legends due to the region's turbulent past, their presence and care of the land provide a glimpse into Yellowstone's rich heritage. Some believe that the spirits of these tribes still inhabit the wilderness of Yellowstone. In the 18th century, this vast area was largely unknown to European settlers, except for a few Native Americans and explorers. Surprisingly, records show that Europeans began to explore these lands in the late 1700s. The famous Lewis and Clark expedition, conducted from 1804 to 1806, played a significant role in mapping these territories. Meriwether Lewis led his group northward to explore the Marias River, while William Clark, a skilled mapmaker and self-taught physician, guided his team southeastward to investigate the Yellowstone area. Although the expedition did not directly enter Yellowstone, it set the stage for future explorations. Fast forward to 1869 when a group of non-Native Americans led by David E. Folsom embarked on the first documented expedition into what we now know as Yellowstone. Their modest journey marked the beginning of a wave of exploration from the Pacific to Europe. Subsequent expeditions, including the renowned Washburn-Langford-Doane expedition of 1870, followed suit. However, the most significant endeavor was the Hayden Geological Survey of 1871, spearheaded by geologist Ferdinand Hayden and sponsored by the federal government. This extensive survey meticulously explored Yellowstone, aiming to document its beauty accurately. Hayden and his team, with artists, scientists, and photographers, spent months studying and mapping the region. Their records were crucial for future scientific endeavors. In March 1872, Yellowstone became the world's first national park based on these explorations. Tales of tremors and turbulence define Yellowstone's seismic activity. Thousands of small earthquakes occur yearly, with most unnoticed. Throughout history, 6 significant earthquakes, magnitude 6 or higher, have occurred. One notable event was the 7.2 magnitude Hebgen Lake earthquake in 1959, just outside the park's boundary. This earthquake shattered the Hebgen Dam, flooding the land and reshaping the Madison River's path. Despite the devastation and loss of 28 lives, communities rallied together, rebuilding what was lost. The area's vulnerability led to significant safety upgrades and emergency protocols. The quake sparked scientific discussion, with some suggesting it caused ongoing earthquake activity. However, not all earthquakes cause significant damage. For example, the 6.1 magnitude quake in 1975 resulted in minor damage. Yellowstone is prone to earthquake swarms, with thousands of small quakes buzzing around like bees for months. In 1985, scientists tied this activity to the Yellowstone caldera, a giant volcanic crater beneath the park. Fast forward to 2007, and the ground under Yellowstone caldera buzzed again, with 16 small quakes in a few days. These swarms are nature's way of stretching its muscles. In December 2008, over 250 quakes rattled Yellowstone Lake in just 4 days, with the biggest hitting a magnitude of 3.6. Then, in January 2010, another 250 quakes shook things up over 2 days. The enigma of supervolcanoes revolves around the Yellowstone caldera, globally renowned as the second largest volcanic feature after the Lake Toba caldera in Sumatra. This colossal structure earned the moniker supervolcano due to its formation through massive explosive eruptions. Beneath Yellowstone lies an immense chamber of molten rock resembling a vast underground lake of lava, stretching approximately 37 miles long, 18 miles wide, and 3 to 7 miles deep. The present-day caldera was shaped by a monumental eruption 640,000 years ago, ejecting more than 240 cubic miles of ash, rock, and volcanic debris. This cataclysmic event created a caldera nearly 1 kilometer deep and 45 by 28 miles wide, leaving behind the remarkable rock formation known as the Lava Creek Tuff. The most intense eruption on record occurred 2.1 million years ago, expelling a staggering 588 cubic miles of volcanic material, forming the Huckleberry Ridge Tuff and the Island Park caldera. Subsequently, 1.3 million years ago, a smaller eruption produced 67 cubic miles of material, forming the Henry's Fork caldera and the Mesa Falls Tuff. Each of these eruptions significantly impacted North America, blanketing vast areas in ash, disrupting the climate, and posing challenges for various organisms. Presently, scientists closely monitor Yellowstone due to increased seismic activity. Numerous earthquakes, including some up to a magnitude of 4.4, have been recorded between June and September of 2017, raising concerns about another major eruption. The primary question that puzzles scientists is the source of this volcanic activity. While some attribute it to processes in the Earth's crust and upper mantle, others believe it originates deeper within the Earth's mantle. The sudden appearance of the Yellowstone hotspot in the geological timeline adds to the mystery surrounding this phenomenon. Another interesting phenomenon is the Columbia basalt flows, big lava flows appearing around the same time and place as the Yellowstone hotspot. Some think they're connected. In 2018, some scientists suggested a new idea that volcanoes are fueled by watery bits from deep below rising from the Earth's mantle. These watery bits might come from pieces of an ancient plate, the Farallon Plate, slipping down from the Cascadia region. Others argued against the idea that a big hot blob in the mantle called a mantle plume is the main cause of Yellowstone's eruptions. They said the sinking Farallon Plate might act like a shield, breaking up the plume's power. So, even if some heat sneaks through, it's not enough to cause massive eruptions. Understanding Yellowstone's volcanic history helps estimate when the next major eruption might occur. However, making predictions is challenging. Despite advanced tools like earthquake monitors and satellite imagery, it's difficult to observe subterranean activity. Yellowstone's geothermal features add complexity. While studying bubbling mud pits is fascinating, they can also be problematic, splattering mud onto equipment and requiring extensive cleanup. Additionally, natural gas emissions corrode metal instruments, raising concerns for researchers. Furthermore, weather conditions pose challenges, with snowfall damaging equipment and lightning strikes disrupting vital communication. Placing equipment in Yellowstone's wilderness requires scientists to embark on challenging hikes. Despite these challenges, this work is essential for various research purposes. Yellowstone's caldera releases hot water and steam every hour and a half to 2 hours, a major tourist attraction. Beneath the surface lie numerous hot springs, boiling pools, and mud flows, all powered by heat escaping from the magma chamber. As water seeps down through cracks in the rock layers, it heats up before erupting, creating vibrant colors and captivating textures. Among these wonders, the Grand Prismatic Spring stands out. The Grand Prismatic Spring is the biggest hot spring in the U.S. and the third largest globally. Its water bubbles at a hot temperature, gradually cooling as it fans out. Vibrant hues paint the landscape in spring, thanks to microbial mats creating colors ranging from greens to reds. The intensity depends on chlorophyll and carotenoids and the water's temperature. In summer, the mats take on oranges and reds, while in winter, they are dark green. The middle of the pool remains devoid of color, heated to extreme temperatures. The deep blue hue at the center is thanks to the natural color of water itself, most pronounced at the heart of the spring. Visitors walk along the boardwalk, witnessing patterns akin to flames, unaware they tread upon heat-loving microbes. These microorganisms revel in the harsh conditions of the Grand Prismatic Spring. As news spread about recent earthquakes at Yellowstone, social media buzzed with speculation and concern. People expressed anxiety and fascination, connecting seismic activity to global climate issues. Yellowstone Park reminds us of the delicate balance of life on Earth and the ongoing efforts to protect it. What are your thoughts on the possibility of a Yellowstone eruption? Share in the comments below.